All right, let's dive right into this explainer. We spend so much time looking at the incredibly human-like text these AI systems spit out, and it's so tempting to just assume there's some conscious, creative little mind hard at work inside the box. But today, we're looking way past the interface. We're going down to the physical wires, the actual silicon, and, most importantly, we are going to celebrate the brilliant human architects who actually built the vital bridge connecting our messy, organic minds to raw, unthinking hardware. So here's how we're going to break this down today. 1. The grand computational illusion. 2. TurboQuant, the hardware bridge. 3. Larkwell, the logical bridge. 4. Forging the semiotic bridge. And finally, number 5, the new human orchestrator. Let's get into it. Starting off with Section 1, the grand computational illusion. We really need to start by shattering a massive myth about how our digital devices actually operate. I want you to think about this question for a second. Do computers actually process meaning? Because when you type a prompt or ask an AI a complex question, it intuitively feels like it understands you, right? The output makes sense to us. But the truth is, that intuition is completely backward. We are entirely projecting our own human meaning onto uninterpretable physical switch states. And that brings us to a massive physical hurdle known as the von Neumann bottleneck. Think of it like a massive commercial kitchen, but the chef is literally miles away from the refrigerator. That's modern computer architecture in a nutshell. Ever since 1945, computers have physically separated the processing unit from the memory unit. So for modern AI, which has to evaluate billions of parameters just to generate a single word, this creates a massive grinding data traffic jam. The AI is physically bound by this bottleneck. It burns immense amounts of energy just charging and discharging copper wires to shuffle data back and forth. The crucial takeaway here is this really stark contrast. There's this vast, fundamental gap between our organic minds, which are, fuzzy, highly associative, and entirely driven by meaning, and the cold, rigid hardware reality. Down at the absolute metal, there is only ALU fidelity. That arithmetic logic unit is driven completely by microscopic physical switch states and clocked voltage levels, nothing else. There is absolutely zero semantic meaning inside the machine, just continuous electrical currents approximating binary arithmetic. It's totally blind to what we actually mean. Which perfectly tees up Section 2, TurboQuant, the hardware bridge. So how exactly do we fix that brutal von Neumann bottleneck? We look to a team of incredible human creators who mathematically solved this hardware crisis. These are the architects of the hardware bridge: Amir Zandieh, Majid Deliri, Majid Hadian, and Vahab Mirokini. Working across places like Google Research, NYU, and DeepMind, these brilliant researchers engineered something called TurboQuant. It's essentially a data-oblivious vector quantization algorithm. Basically, it's a hyper-efficient way of packing and unpacking data that completely bypasses that physical memory wall, and it does it without needing any training data or codebook calibration, just pure, elegant math. To put that into perspective, the sheer scale of this achievement is just staggering. They managed to compress the massive key-value cache down to a tiny 3 bits per scalar, with literally zero loss in accuracy. We're talking about taking a dataset that used to hog 31 gigabytes of RAM and shrinking it down so it fits comfortably into just 4 gigabytes. It is absolutely incredible. So, how did they pull off this magic trick? Well, instead of using heavy, clunky machine learning, they relied on strict geometry. First, they normalized the vector length. Then, they apply a random orthogonal rotation, which basically makes the coordinates predictable. Next comes the standard scalar quantization. And finally, they use a 1-bit quantized Johnson-Lindenstrass transform, which, if you're not a math major, just think of it as a brilliant mathematical error checker to completely eliminate bias. They literally solved a massive physical hardware bottleneck using nothing but precise mathematics. All right, moving on to Section 3, Larkwell, the logical bridge. Okay, so we've bridged the hardware gap, but we still have a huge software crisis on our hands, the impenetrable black box of neural networks. Enter the architect of the logical bridge, Chris Hayuk. He looked at the system and realized that while the hardware was optimized, the weights inside the model were still essentially being treated as opaque binary blobs. So he built a solution. He created the Lazarus Query Language, or LARQL, which fundamentally shifts how we interact with transformer layers. Hayek's engineering totally flips the script on the old paradigm. He essentially decompiled the model's feed-forward network into a highly structured, editable database known as a vindex, or vector index. Think of it like taking a giant solid block of concrete and turning it into a perfectly organized, transparent filing cabinet. Instead of opaque black box blobs of weights, we suddenly have transparent, queryable SQL-like relations, and instead of uninterpretable nonsense, we get a fully auditable knowledge graph. Hayek really hit the nail on the head when he said the model is the database. Query neural network weights like a graph database. No GPU required. This is a total game changer. It allows practitioners to literally audit, patch, and control the internal knowledge representations directly. By decoupling the attention mechanism from the feed-forward network, you can trace the exact path of how a model arrives at an inference. You can even patch its knowledge without having to retrain the entire model from scratch. And that brings us to Section 4, Forging the Semiotic Bridge. So what exactly happens when you combine TurboQuant's mathematical edge execution with Larkal's structured graph auditing? You get the semiotic bridge. Because our organic minds are so fuzzy and the arithmetic logic unit is so incredibly cold and rigid, we desperately need a translator. And these creators forge the ultimate bridge using text and code. Text is that highly exact, deterministic medium that lets us take our boundless, nonlinear associative imagination and safely map it directly onto physical silicon. To put it playfully, we are quite literally tricking rocks into thinking using lightning and highly structured text. This builds a really fascinating unified abstraction ladder. Think about it. We start at the very top with fuzzy, messy human intent. Then we funnel that down into text or pseudocode, structure it through Larkal's auditable logic, and finally hit the unyielding physical execution of the hardware with TurboQuant. At every single step down that ladder, we are deliberately trading away our expressive human freedom in exchange for strict mathematical certainty. Which leads us to our final part, Section 5, the new human orchestrator. This entire brilliant architecture points to a really profound philosophical shift. We are moving away from a model of pure origination to one of strategic management. In this setup, the AI is fundamentally just acting as a von Neumann Babelfish, like the universal translator from Hitchhiker's Guide. It's mechanically orchestrating meaning between sequences, but the actual associative thought, the real spark of intent and meaning, that originates entirely with us, the humans. And honestly, when things go wrong, which they do, manual human intervention, the literal sweat of the brow, is absolutely required to go in and maintain bit-perfect fidelity. We aren't being replaced here, rather our supervision is becoming permanent and completely indispensable. It really is the death and rebirth of the author. We surrender the mechanical rendering process to the AI, sure, but the overarching moral and strategic intent remains fiercely human. The romantic idea of the solitary genius having a lone epiphany is literally evolving into the strategic management of a system. We are becoming the algorithmic orchestrator. We provide the rhetorical technique and the initial prompt, and these incredible tools, built by brilliant engineers like Hayek, Sandiai, Daliri, Harian, and Marachni, they handle the rendering. I want to leave you with this final, somewhat provocative thought as we wrap up this explainer today. As computing interfaces continue to evolve and that semiotic bridge between our minds and the hardware continues to shrink, what happens if we remove the human author entirely? Because as these deterministic systems start executing physical actions out in the real world, it is entirely up to us, the human orchestrators, to maintain deterministic safety. If we stop writing the bridge, who controls the physics? Think about that for a bit. Thank you so much for joining me for this explainer. Keep wondering, and I'll catch you on the next one.